Hello, this is video number 23. I'm going to talk about weight in this video. So you want to think of weight as a gravitational force. Weight is your gravitational pull of the Earth on an object. The Earth is pulling an object down. That is what the weight is. So the weight depends on the mass and the location of the object. The expression that we have for weight, which you can call a Fg or W, is mg. So you can see that it does depend on mass, because the more mass you have, the more weight you're going to have. It also depends on location, because g is the acceleration due to gravity, and that does depend on your location. If you're on the moon, the acceleration due to gravity is different. So technically, the definition here, it could be the gravitational pull of a large body. It doesn't have to be the Earth. It's just in this class we're mostly going to be on the Earth, which is why I put the Earth here. But if you're on the moon, you'd have weight on the moon as well. The direction of the weight is straight down. It is a vector. It has that magnitude and the direction. And weight is a force, so it has units of newtons. You don't want to get weight and mass confused. This is coming up next in the next slide. I have a note here that 1 Newton is approximately 0.225 pounds. So the pounds that you're used to are a unit for weight. So this is just a conversion factor. Notice that I did not put a conversion factor with kilograms. Kilograms is a unit for mass. And just one last thing I want to touch on here, where this weight is equal to mg. This should make sense to you, because we learned that force equals ma. If this object is in free fall, well, we already know that the acceleration of this object is g. So the weight of the object is its mass times its acceleration, which would be m times g. So let's compare weight and mass. You may use these terms interchangeably, but they're very, very different. Weight, you know what? It looks like I have these switched here. Let's switch these here. All right, that was really bad. Mass is the quantity of matter in an object. We talked about this in a previous video. It's also a measure of the object's inertia. It does not vary in classical physics, which is what we're going to deal with. In relativity, when objects are moving really fast, their mass may change, but in classical physics, mass does not change. The unit for mass is kilogram. It's a scalar. It does not have a direction. Weight, on the other hand, is a measure of the gravitational force on the object. It varies depending on gravity. The unit is a Newton, and it is a vector. So they are very different quantities. One thing that you want to remember is the units. These can actually be very helpful. Let's say that a problem says, hey, there's a 100 kilogram person that is standing there doing all this stuff. That's the problem says this. By just looking at the unit here, you see kilogram, then you know, hey, I'm actually given the mass of the person. But if the problem says, hey, there's a 1,000 Newton person doing so-and-so, then that Newton implies that it's already giving you the weight of the person. This is very important, because sometimes you're given the mass and you still need to convert it to weight. If you're already given the weight, you don't want to do any more conversions most of the time. So hopefully this helps show you the difference between mass and weight. And the last thing I have here is a quick example. A person has a mass of 81 kilograms on Earth. What's the weight of the person on Earth? So weight equals mg. The mass is 81 kilograms, and g on Earth is 9.8 meters per second squared. Multiply these two, we'll get about 794 newtons. Part B, how much would the same person weigh on the moon? Weight is still equal to mg. The mass has not changed. Mass is still 81, but now the acceleration due to gravity on the moon is smaller. It's 1.67. You multiply these two numbers together, get about 135 newtons. So this is what the previous slide meant, that weight does depend on location. On the moon, you weigh less than on the Earth, but your mass has not changed. So that is all I have for this short and sweet video on weight. There will be another video coming up soon that talks more about this gravitational force due to the Earth and a force that's between the Earth and all other objects, but we'll save that for a different video.